going on, everybody? Welcome to the first in a series of videos that I'm going to put together for some new electronic devices that I'm building for the brewery downstairs. I'm trying to get a little better handle on some of the monitoring and the control, and this video is going to be about building a floating hydrometer. It's based on the DIY Floaty. A gentleman in France put it together. You can buy them pre-made, but they also have plans to do it in a DIY setting. This one has the ability to not only monitor your specific gravity as your beer ferments through, but it also has the ability to monitor the temperature, and it will tie in with the Brewfather app and provides automatic updates as it goes through. It's configured with Bluetooth and connects to the Wi-Fi for the continued update. Also tells you what your temperature of your wort is as it goes through the fermentation process. So let's dig into this and take a look at what some of our components are. The first one we've got here is the 3D printed carrier for it. The battery will mount in here, and then the ESP8266 sits in there as well. Now I had to do some modification to this one. The V2 version actually has another brace that comes out here that I had to clip off. My ESP8266 or 32, whichever you choose, is a little bit different. It's a little bit bigger than the one in the plan that they call for. Not a big deal. It still fits the way it was supposed to. Put a battery in the carrier back here. Now this is a 18650 battery, a 3.3 volt battery. They say that the battery life is good for anywhere from 6 months to a year, depending on how much it's used. But to recharge it, it's pretty simple. You just plug your ESP32 into the USB port. There's a ESP32. It has the header pins that come with it, and these will be used. Some of these will be used to put the MPU 650 or 6050 on it. The accelerometer that's used to actually figure out what angle the hydrometer is sitting at. There's the MPU itself. This guy has the accelerometer on it that tells the processor what angle the actual unit is sitting at, and then that information is what the specific gravity is derived off of, and that'll mount to the board something like so. We'll get into that here in a little bit. And then we have our 18650 battery, 3.3 volt. When I started this, I was starting to kind of figure out if I could use a AA battery, but as I researched it, I realized I can't now that I actually have the battery. Yeah, I see that it's AA is not going to work at all. And like I said, this mounts in your carrier here with the processor set in here like this. This whole unit is then slid into, it's actually a geocaching tube. Unfortunately, for some reason right now, I can't find these in the United States. I had to order them from a European seller. It actually came fairly quickly. Within, I think, 2 weeks I had it. But this whole assembly then slides in here. And it's a tiny bit snug on the end, which is kind of not a bad thing, because it keeps this whole assembly from sliding as it sits in the liquid. And then your cap is screwed on. As it sits in the wort, the angle changes, which is what determines what the specific gravity of the wort is. There's a program that will flash to this as well, and it's provided by the gentleman that put together the Floaty to begin with. It is not open source, and I don't blame him. I mean, if I put together the software, I'd keep it kind of locked down for myself as well. However, he's very good about responding if there's problems. Watching through some of his YouTube videos on the channel, he's very, very good about responding to comments. But let's go down to the garage and start putting this whole thing together. Alrighty, buddy, welcome to the garage. We're gonna go ahead and start working on putting this thing together. A couple things we need to do first. One is to get a couple wires for the power and ground, and then we also need to find an LED that's on the MPU 6050 and remove it. I'm not really sure why they have you remove it, but I'm gonna go ahead and do it just because that's what it calls for. Let's go ahead and get into this. So the first thing we've got here is the LED that is just off the side of the MPU 6050, and you can see it there next to that, or off the side of that ADO port. Notice the Y with the arrow pointing up, and the actual LED sits there. So we're going to pop that off. Got that off. Now we need to get our header pins trimmed down for what we need here. So for this, we're only going to be using the VCC, the ground, the SCL, and the SDA. So they're just those 4 pins that need to go. So now the VCC corresponds to pin 33 on our ESP. It corresponds to pin 33 over here. The ground corresponds to pin number 25, which is, I believe all of those are right in this area. So 33, 25. We should have 26 on here is the SCL here, and then 27 is the SDA. We're gonna go ahead and trim out the 4 pins that we need, the header pins that we need for the MPU. And these easy, they break real easy, they just snap right off. I have not pre-tinned this, but I will here after I make sure that everything fits in there the way I want it to. Okay. So I want to leave a little bit of this material here as a standoff for when it mounts into the MPU, or I'm sorry, into the ESP32, just to keep it above the level of the Wi-Fi module here. So, you know, we got to go double check my reference here. We got to go into VCC goes into 33 and the ground goes to 25. So we have 33, 25, 26, and 27. So this is going to sit in here just like this. But notice how keeping that offset like that has made sure that it's not going to sit and rub it right against the Wi-Fi module. sure we got good flow around everything, and it's not going to create a bad connection later on down the road. And we will put each one of these tails off. Okay, so that gives us our ESP with our MPU on there. Now we need to be able to get power to the board. And I almost messed up because the voltage in and the ground are right here. I don't know if you can see them right underneath the board, but that's okay because we'll come in from one side with the ground and then the other side with the power. So flip our ground wire through there. And I've already pre-tinned these, so they should flow fairly well. Again, we're going to clip our ends off. So that's the board assembly itself, and then we've got power. Now this board assembly has to find its home in on our carrier, right? So this unit is actually going to sit in this just like this. The positive end sits up here, our negative end has to go down here. And we want to make sure that we leave a little bit of extra so that if we need to pop this board up and out, we can. Actually, one thing I almost forgot about that we need to do first is we need to solder one of these guys onto the pin 15 spot on the MP or the ESP. This is what serves as the D15. We need to make sure that there's enough extra wire on the positive side, which goes to here, and on the negative side, which is going to go back here, to facilitate being able to get the board in and out. Now, the way this 3D file prints, there's a hole in the case or in the counterweight back here, so we can run that wire through there just to kind of keep things a little bit cleaner in the final installation of it. So we'll put that in there like that and just lay it down in there so it's nice and neat. See the red LED under there? It's a pretty good indication that we've got sufficient power for our system. So once it's all set in here, it should look something like this. The next step in building our Floaty hydrometer is to configure the software for it. Now, if you go to floatyhydrometer.com, it takes you to the home page for the developer of the Floaty. They have systems available for purchase, and they come in at $89 euro, I believe. But if you go to the DIY tab and open that, it'll open the YouTube video for it. And in this YouTube video, there all of the Google Drive links and whatnot are attached in the description. So we'll go ahead and look at that. If we go to the description here, it shows the app, the supply list for everything that's needed, and then the Google Drive as well. I've already got the Google Drive opened up. So if we look at this, we've got two different setups here. There's the 3D printing and then the Flash Tool Zip and the Floaty.zip. So for the 3D print, these each contain the STL files for the support. And I went with the Floaty support version 2. But what we're interested in is this flashtool.zip and the floaty.zip. Now, I had some problems with the flashtool.zip when I tried to download it and use it from the page here. So what I ended up doing is going to Espressif Systems and pulling their flash download tool. It's the same one. This one just downloads it straight from Espressif. So we'll download that. And then the next thing you need is in this floaty.zip file. We'll open that with the zip extractor. This contains all of the configuration files for the Floaty. So these, the bootloader, the boot app, the floaty.bin, and the Floaty partitions, INO partitions. Now, I've already downloaded those and saved them on my computer for easy access, but you'll see them here. In this file, there's also a JPEG, or a PNG rather, that's called new procedure. So if you watch through the YouTube video, it shows just uploading the one floaty.bin folder or a file. However, all four of these need to be uploaded to the microcontroller in order for it to work. So at this point, we'll go ahead and plug the Floaty into the USB port on the ESP32 and into your computer. And we will open the Flash tool. And it should open with a command prompt window and then give you this download window. So the chip type, we need to set that to ESP32. Leave this in develop, and then load mode should be in your. Click OK. And here we have our SPI download files. And these are the ones that were in that Floaty zip file. And you just click on the three dots over here, and it allows you to go in and select which file you want to upload. So as you notice, I've already got everything already in here. These values are critical. This 0xe000, 0x1000, 0x10000, and 0x8000. After you have those inputted, make sure that these four check boxes on this side over here are checked. The SPI speed is 40 megahertz, the DIO SPI mode, and then do not change bin. And we'll make sure my computer is detecting it on COM6. That's the one it's always detected it on. And then the baud rate should be 921,600. And it's just as simple as clicking the start button. It'll go through the download process. And as long as you see the flash vendor, the crystal speed, and then download over here on this green box on the left-hand side of the screen with the green status bar going, you know it's working right. Now it says finish, and that's it. That's all there is to it. The next step is to configure it through the app. And the app can be found on the
Google Play Store. They don't have one available for Apple or iOS yet. This is just the overview of it on the computer. We'll step over to the app and keep going with the configuration.
And setting our Floaty up is to configure it through the app. So to do that, go to the Play Store. We'll download the Floaty Wi-Fi Hydrometer app. I've already downloaded it, so we'll go ahead and open that up. This is the screen that it opens up to the first time you use it. This little plus button down here in the corner is to add a fermentation. What we want is settings. So we have to add a device. So in the middle of the screen we see Floaty and we see add. So we'll click on the add, and it's going to start looking for the Floaty through a Bluetooth connection. Now I found it easier to do this with the Floaty plugged into a USB power supply rather than trying to do it with the battery. So what we'll do is we'll click the Bluetooth device search and then touch pin 15, the header pin that we installed on the board, and it shows up with the Floaty. So we'll click next. I've already named this one. We'll go next, and this is a V2, so this was the version 2 support, and it asks you here which one you want. So we got V2, and then the Wi-Fi network that you're going to be configuring it on. So we got my network ID in there. Enter the password. And it goes through the Floaty initialization now. So now after this, the Floaty will be paired. At this point, you can go ahead and start using it. The next step though would be to calibrate it, and we'll go through that. I need to go get a bowl of water because we'll have to fine tune the angle at which it sets. And it's so here it says update your Floaty. So in order to do that, we go back here and we just click on our Floaty and then click update. And it's going to go through the update process and download the firmware updates for the Floaty itself. And it sometimes takes a minute or two, just depending on how good your Wi-Fi connection is and how fast the processor is working with it. Now we can go into the calibration center, select the Floaty, and it'll connect through Bluetooth. All of the calibration with this is done via Bluetooth. Sometimes it decides it wants to not play nice. We'll touch the pin again, it turns the Bluetooth back on. So here's our calibration screen. The one that I'm going to use to start with is a single point calibration. And in order to accomplish the single point calibration, notice here it says beta only for Floaty with angle of 30 degrees. So we'll put the whole Floaty together and put it into the tube, and it will counterbalance it so that when you put it in water, it sits at 30 degrees. Now ideally, distilled water would be the best for this. I'm going to use tap water. My intent for this is not to be completely 100% accurate for my final gravity. What I want to do is track my fermentation as it progresses, so I know when fermentation is over. So we'll go ahead and set up for that, and we'll do the calibration next. The last step in putting our Floaty together is to do the calibration. And as I said before, I'm not trying to get pinpoint accuracy with this. This is to give me an idea of like the fermentation process, where it's at. So for this, I'm going to do the single point. There's a couple of different ones that you can use, but we're going to do the single point because it's setting the degrees for the thing to float at and checking it in water and calibrating it. So to do that, we're going to go in here and make sure that we're connected with the Bluetooth, little Bluetooth symbol in the corner there. We're already connected up. We're going to go to the calibrate. We're going to go to angle. Make sure that the Floaty and the carrier and everything is in the case or in the tube the way it needs to go. And we're going to set it in a bowl of water here.
I'm just using regular tap water because I'm not trying to get pinpoint accurate. The most accurate way to do this would be to set it in distilled water. However, not really necessary. Bluetooth tried to disconnect. Get that to connect back up. And you'll notice it says put your floaty in water in an angle between 25 and 35 for proper function and ballast. That's where we're going to calibrate. It sits in our bucket of water and kind of settles out. We'll notice we're sitting 19 degrees. So I've got a dime in there. I kind of messed around with this. We'll take that dime out. Obviously, it's setting too much in the bottom of the tube. The dime down in there. Get rid of that. And again, we'll set it in where it floats at. As long as it's between 25 and 35 degrees, it should calibrate out just fine. Try to carry it all the way down into the bottom of the cup. Looks like we're sitting between 30 and 33. So that's good for where we need to go. So now we're going to go into our calibration center. Do the single point, hit calibrate. And that's it. Let's go. So now our floaty is calibrated and it can be dropped into a bucket of wort. Away she goes.
All right, there we go. That's how to build a DIY floating hydrometer from the Floaty Hydrometer website with the 3D printed STL files and the other open source components. One thing I did figure out is the first place I hooked up the power and ground wire on the ESP32 was the regulated voltage input. It's capable of, I want to say, between 6 and 12 volts. The 18650 battery is only a 3.3 volt battery. So what I ended up doing is moving the power and ground wire over to the 3.3 volt spot on the ESP32 board. I was a little hesitant to do this initially only because the battery itself had 5 volts on it, and I was a little scared that I was going to smoke the board, but moving that power and ground wire over fixed some of the connectivity issues. And it's actually currently sitting in a salt and lime lager that's in the fermentation chamber. I'll have a video coming up for that here shortly, probably within the next week or two. Wrapping it up, if you guys like the content, you want to see more of it, subscribe to my channel, like the video, and then hit the little bell for the notification so you get notified anytime I put some new content out. We'll see you in the next one.